We're going to prove that two segments are congruent. I know proofs can be really challenging, and you might watch this and it might make sense to you what I'm doing, but you might think to yourself, I wouldn't have been able to come up with that stuff on my own. But keep trying, keep watching more examples, keep practicing, and you'll eventually notice some patterns and you'll pick up on it and get better at them. I'm going to write this proof as a flowchart because I think sometimes that can be easier to follow, but I'll show at the end what a two-column proof would look like. We always want to start with what's given, so AB is congruent to CD, and that was given. And that means that their lengths must be the same by definition of congruence. Then we want to incorporate AC and BD somehow in our proof because we need to end up with those. So when I look at the drawing, I see AC, AB plus BC is AC. Even if I don't know how that's going to take me to the end, I'm going to write that and see if it takes me anywhere. That's the segment addition postulate. And we can write BC plus CD equals BD. There's that BD we need and that AC. So right now, we want these two to be in our answer. So let's look at the left side. If one side of one equation equals one side of the other equation, you can combine them and set those parts equal to each other. They both have a BC, and ideally this AB would be a CD, or this CD would be an AB, because then the left sides would equal each other. We know that AB is congruent to CD. Their lengths are equal. So instead of AB, we can substitute CD. That was substitution. And now the left sides are the same. We have BC plus CD, CD plus BC. And if you want to rewrite that BC plus CD, just change the order, the commutative property. So now you see that the left sides are equal exactly. Now we can combine the two equations into one and say that AC equals BD. That's called the transitive property. If A equals B and B equals C, then A equals C, because they both equal the same thing, so they both must equal each other. And that means that since their lengths are the same, segment AC is congruent to segment BD by definition of congruence. Here's the proof written out again, but neater. And here's a two-column proof.